I will have an introduction slide first, and then we will introduce you to the stage later. Hello, สวัสดีครับ Okay. Good evening, dear member guests, sponsor, ladies and gentlemen. Welcome to SPE Thailand technical meeting for August. For those who don't know me, my name is Warapat Phongpitakul. So I will be the MC for tonight. In 2023, we continue with our mission to keep you informed of what is going on in our industry and make new knowledge available to you with monthly technical presentation. Tonight, it's our honor to have Kun Tom Emelander to share us about Sidetracking with Whipstocks, an efficient method for increasing your operational and asset value. Our vision is to be open to share information with our peers across the company, so we can provide energy to the kingdom and of course meet the new face. And the most important is to see the smile on your faces. Okay. Tonight's agenda, we have a couple of announcements regarding our SPE Thailand section, followed by our main presentation with talk by Kun Tom Emelander. He's a product line manager from Weatherford. Hopefully there will be some time for the question. Then we have a couple of closing remarks. And finally, we do the lucky draw. For the section announcements, Thailand section valid membership as of today is 655 members. This is combined 411 professional and 244 student members from Chulalongkorn, Suratnari, Prince of Songkhla, and Chiang Mai University student chapter. We're glad to see our professional members keep growing up in climb momentum. However, we still have around 91 professional membership from 2022 who has not yet renewed their membership. May I remind you to please recheck your membership status and renew. And to all of us, please invite a colleague to join our meeting for even better join SPE, because we always need a new member. SPE Thailand is still the largest professional oil and gas industry organization where you can regularly meet and greet with relaxed environment. For the membership benefit, there are plenty of reasons why you should maintain a valid status and even more reason to join SPE. I will not go through all the elements of them as you can see on the screen, but worth mentioning that the key benefit of belonging to one of the most active SPE section in Southeast Asia, and are the regular opportunity to network, share knowledge, and socialize with peers of the same interest in our industry. This company are sponsors who support us, our Thailand monthly technical meeting for this season. For any of you who may have just joined to this meeting, if you would like to see your company name in here, please reach out to us. We appreciate your support, and of course, our society needs you. So for the speaker introduction, let me hand over the microphone to Mr. Tak Meng Chia, our co-program chair, who will honor introducing our speaker tonight.
Thank you, Warapat. Good evening. So it's quite happy to see many familiar faces and some new faces. So welcome and thank you. So today we are delighted to have Tom Emelander with us, an SPE distinguished lecturer, all the way from United States to deliver his lecture. So Tom started out his career as a mechanical design engineer in the industrial sector, and shortly after about 2.5 years, he was recruited by Weatherford, and as a technical sales specialist for about 8 years. Then he was promoted to US Geozone Operations Manager and followed by North America Geozone Manager. And currently he's the product line manager for Whipstocks Systems, which is a topic that we're going to talk about today. So Tom has been regarded as one of the subject matter experts in casing exit technology. And throughout his career, he has authored a number of publications in OTC, SPE, World Oil, and Tom graduated from Western Michigan University, major in mechanical engineering and minor in mathematics. So without further ado, let's welcome Tom to deliver his lecture.
Thanks everyone for coming. Talking about Whipstocks and Sidetracking tonight. First time to Thailand, quick trip, very much enjoy it. With that, we'll get started. Hang on a second. There we go. All right, so the agenda for tonight, talking about sidetracking. So we'll give a definition of what sidetracking is from a high-level standpoint, why a lot of operators globally do it. Then we'll speak a really high-level view on exactly what whipstocks are, how they play a portion of sidetracking, the process of it, the different components that make up the actual BHAs, and then we'll finish up that section with some of the alternatives to sidetracking. And then we'll get into kind of the meat of the presentation, the evolution of sidetracking. So where sidetracking started, kind of the metrics at the time, and then where we're at today from a technology standpoint and also statistics. Then we'll move into contingency sidetracking. The reason I have this as a standalone topic is because over half the sidetracks done on a global standpoint are done in contingency mode, meaning you have a rig on location, something's happened, sidetracking becomes an option. We'll take another high-level overlook at multilaterals and reentry, so utilizing mature field assets to gain behind pipe production. And then last but not least, we'll finish up with open hole sidetracks. At the end of each one of these 4 topics, we'll have case history. Most of it comes from in-region. We got one from Thailand, and then I also put a unique one in there from the Gulf of Mexico. So definition of sidetracking, I pulled one of the definitions out of the oil field glossary, but the picture kind of speaks 1,000 words. So anytime you depart from the original wellbore, it's a sidetrack. It doesn't matter what the geometry of the well is. As soon as you deviate from the original wellbore, it's a sidetrack. So lots of reasons why operators do them. There's quite a few listed up there, and we'll go through a lot of these, but kind of one of the main ones I already referenced was contingency sidetracking. So I've got up here as main bore impasse. So anytime you're on location with a rig and something happens like stuck pipe, clap casing, missed target, any of those unique scenarios, a sidetracking becomes an operation to get you back to drilling quickly. There's some other ones up there, regulatory I'll speak to, that's kind of a very rise here recently. Getting new drill permits in certain basins around the world can be an issue. A lot of times re-entering old wells, getting permits to do that is much easier. And then, of course, with ESG targets becoming also topic for conversation globally, a lot of the times you do a sidetrack out of existing well, it's considered green, right? Less trips, saving well construction down to the kickoff point where you'd actually set the whipstock. So just a couple mentioned up here. We'll go through a lot more as we go through the slide deck. So the most important slide, at least on the front end of the deck, what is whipstock? So as we have up here laid out at the bottom of the screen, it's just an example of what a casing exit looks like. So in this particular instance, it's inside a casing, it's out in a horizontal, the window's cut in a high side direction, the milling BHA is already out into formation. So for the most part, the sidetrack has been done, and the next trip in will be the drilling BHA. So how do we get to this point? Anytime the decision is made to sidetrack, whether it's planned or unplanned, usually a wellbore preparation run or a clean out run is made prior to picking up the actual whipstock assembly. So usually that run's made with bit, mill, scraper, something to go down to the target depth of where you plan to set the whipstock to ensure you can actually get the system to depth. clean it out, clean out any debris, over torque casing collars, do a fluid swap. After that run is made, you will pick up the whipstock assembly, anchor first. What I've got pointed out with the yellow arrow, whipstock second, that's the actual deflection device. And then typically in cased hole, your method of deployment is going to be 1,000,000 BHA. So you cut the window in the same trip that you actually install the whipstock system. Above the 1,000,000 BHA, which will be pinned to the actual top of the whipstock with a shear bolt, will be your directional equipment. So either UBHO sub for wireline orientation or MWD, LWD, something to point the actual whipstock in the direction you want to sidetrack. Above that will be your weight pipe, inline magnets if you're going to run them, and then drill pipe to surface. So this whipstock will be tripped in very slowly because it's on a shear bolt down to the target depth. It'll be orientated to the direction you want to cut the window. And at that point, you will either set the anchor hydraulically or mechanically. We'll get into the details on that in a second. And then at that point, once it's anchored into the wellbore, you will separate the milling BHA and cut a window. So cut a window in the casing. You'll usually get all cutting structure outside of the window out into formation, and at that point, you will come out of the hole, and the next run will be your drilling BHA to actual start the sidetrack process of the well. Okay? So the components, starting at the bottom and working our way up, the anchor, as I mentioned, you will either set that mechanically or hydraulically. In this case, as shown, it's hydraulic. There's no false bottom below it. But if you're going to run a system mechanically, you have to have something in the wellbore to set it on. And it doesn't matter what it is. It can be a bridge plug, liner top, fish top, cement, but there has to be something to set down on. The other option is obviously hydraulic, where you don't have to have anything, okay? Now, a lot of these systems out there, the vast majority of them run globally, are retrievable. And that doesn't necessarily mean that you plan to retrieve it out of the wellbore, but it's always better to run something that you can pull out of the wellbore rather than something you can't. So if you run into a problem, you're not fishing a permanent system, right? So hydraulic is kind of the norm. And then there are options to run these anchors with or without seals, right? If you need pressure integrity across the actual system and you don't have a false bottom set, you can run anchors that do provide you a pressure differential. As shown here, they're running one that does not provide a seal. Directly above the anchor would be your actual deflection device. I've got it pointed out as the whipstock itself. Other people refer to it as a concave. But the main component there, that's what drives your actual mills, the cutting structure out into the casing to actually cut the window, right? So the whipstock OD will be dependent on the casing size of which you're exiting. Obviously, as you get bigger in casing or open hole, the larger the system goes. The main thing to keep in mind with these systems, of course, is the length of window also increases as you go up in casing size. But one thing is very true from an industry standpoint: you do not cut windows longer than a joint of casing. Okay, so the longest windows you'll cut are typically in the 12¼ drift casing sizes, and those will be roughly around 30 feet. As you go up in casing size, the windows do not get longer, and as you go down in casing size, the windows get shorter. Okay. Now, as a rule of thumb, when you're talking about, hey, we're going to run a whipstock, what system do you pick? A lot of it is based off of the face angle of the actual concave. That'll determine the length of window you're going to cut and the dog leg that you're going to have across the junction. Usually when you're talking offshore systems where you need the longer windows, the lower dog legs for the well construction design and the complex BHAs that you're going to run, it's 1.5 degrees to 2 degrees. Now, when you're talking land-based operations, the degrees are typically a little bit steeper in the 3 or 4 degree range, and you do not need windows that are as long in an onshore operation. And then when you start talking about milling BHAs, the milling BHAs themselves will somewhat match the face angle that you're running. So for the shallower angle systems, the 1.5 degrees and 2 degrees, you will run more mills, 3 or 4 mills, maximize window length. For the land-based systems where you're 3 or 4 degrees, you'll usually run 2, maybe 3 mills, not as long of a window as needed. And then of course, the application will drive the actual cutting structure that you run with the mills. So the vast norm of installs are done with carbide and carbide inserts. In certain hard formation applications where you don't have a technically challenging casing exit, you can mix in some PDC cutters for a hybrid type drilling BHA. But for the most part, all those mills will be dressed accordingly appropriate to the application. And then last but not least, To release that million BHA from the whipstock once set, the norm would be to shear it mechanically in an up or down direction, but some of the newer systems that are coming to market, which I'll speak to in just a few slides, can actually be hydraulically released. So if you're in an extended reach application or you don't have the ability to set down or pick up a bunch or set down a bunch of weight, unless you're rotating, hydraulic release certainly becomes an option. So alternatives to sidetracking with the whipstock, I got a couple of them up here. Section milling is one of them. Similar type concept where you're cutting a hole in the casing, but in this particular instance, you're actually milling up large amount of footage of casing, right? So when you think about that conceptually, it's not challenging to do. A lot of service companies out there are really good at milling. Milling up casing is not a real big problem. But when you're talking about milling up entire sections of casing, you're limited on how quickly you can do it because of the amount of swarf that's coming out of the hole, the metal cuttings, right? So you're usually limited to a couple foot an hour. You got to deal with that large amount of steel at surface. From a QHSSE standpoint, that can be problematic. You got to have extensive mud programs to lift that amount of cuttings. And then when you're done with the section milling operation, which may take more than 1 or 2 trips, depending on how much casing you need to remove, you're then in cement plug sidetrack mode, right? So you pump your cement plug, you wait for it to set up, and then you come back in and time drill off of it. If you're unsuccessful with that operation, you got to rinse and repeat the process. So as simple as what it sounds, it can be very time consuming, which a lot of times drives operators more to the fact of doing sidetracking with whipstocks. There are certain basins around the world which still do section milling depending on what size they're in. Usually it's shallower depths and very large sizes of casings, but for the most part, worldwide, people choose to do sidetracks with whipstocks rather than section milling. And then I have listed up there drill a new well. Well, if you've got the CapEx, you got the acreage or the slots, that's always an option. But you do have to consider this, and we'll speak to this heavily when we talk about reentries and multilaterals, is every time you drill a new well, and it's not a bad thing to drill a new well, we do it all the time, right? But when you look at it relative to, say, utilizing something that's already in place, say in a contingency scenario, you have the cost and time of doing well construction down to the kickoff point where you actually set the whipstock. In addition to that, you have all the surface infrastructure, the pipeline and everything to get to that. And then last but not least, you have to abandon that additional well, which in some basins around the world can be the most expensive part of the operation. So to the meat and potatoes of the presentation, the evolution of sidetracking, where it started was the 20s and 30s, Long Beach, California, using slant rigs to target offshore reserves. At the time that sidetracking with whipstock started, the goal was, I hope I get a usable window, right? So it might take you multiple runs, or it would take you multiple runs, and the time frame in which you could do it would often be significantly more than a week, and at the final product may not be a usable junction, a usable window. So obviously the metrics have changed. At the time this was developed, it was only the most common casing sizes, 7-inch and 9 5/8 that whipstocks were done with. Nowadays, for the most part, if it's 22-inch casing or smaller, you can cut a window in it. Doesn't matter. The metrics have also changed. It's all about getting back to drilling as quickly as possible, planned or unplanned, right? Accessing production, accessing the most production possible and doing it as quickly as possible. That's what everything is about, and that's what the focus of this presentation will be about. So lots changed since obviously the 20s and 30s. This particular technology that we're focused on tonight has changed drastically too. The success rates have changed, the trip counts changed. We'll go over those statistics, but the reason why we're at where we're at now from a success standpoint is because the service companies spend gobs of CapEx to make sure that the product you get is reliable, to get back to drilling as quickly as possible, especially when you're in contingency mode. So tens of thousands of runs done since the 20s and 30s. On average, I would say when we're not in a pandemic or a downturn, the amount of whipstocks done globally per year is around 1,500. So that's quite a few. And because of that, there's known risk profiles for a lot of them. So very rarely does anyone come up with something that hasn't been done before. So a lot of the installs are just rinse and repeat, and because there's been hundreds, if not thousands, of the routine ones done, there's standard risk profiles for all of them. We know what the success rates in those applications can be, what the downside is, the well possession times. When you take all this information, what you come up with, at least nowadays, is that as a global average, you can get back to drilling or sidetracked in 3.5 days on average. That is incredibly significant relative to even where we were 5 or 10 years ago. So the well possession time to get sidetracked has dropped, and it's for two reasons. The single trip success rate has skyrocketed. So in most every application you deal with, it's above 95% for all sizes, meaning that the gap between that and 100 doesn't mean that you don't get a usable window. It just means it's an extra trip, which is very well defined as far as the well possession time that's going to take and the cost it's going to be when you know your spread rate. So if I were to say 97% of the time you can get back to drilling in normal applications 3.5 days, that changed the way the industry looks at sidetracking with whipstocks drastically. So we'll focus on that, right? How did we get to that point of 97% success? A lot of changes. Some of it has to do with cutting structure. So dressing the mills with advancements in carbide, PDC, and some hybrid scenarios. It's not only decreased the mill time on a global average, but it's also made milling through more challenging casing exits possible, and decreases the trip count too. So in unsupported applications where you don't have cement behind pipe, it was almost a guarantee that even 5 or 10 years ago, you would have to make an extra trip because of gauge loss. Nowadays, you lose about 20% chance, 15 to 20% chance of getting it done in one run, which is also significant. So the technically challenging installs that were going to be multi-trips because of cutting structure advancements are now done much more from a statistical standpoint in one run, which of course reduces the well possession time. And then as always, the more you do operations, the more data you collect, the more efficient you get, the more lessons learned you have in place. So with these thousands of casing exits being done, this data is collected to make the milling operations more efficient. And then last but not least, I'll speak very quickly to kind of the new technology that's hitting the market here in the past couple months and over the next 18 months. We've kind of maximized the opportunity to get single trips installations done. We're at 97% from a global standpoint. So you have to start looking for other places to save time. And one of those type of saving methods would be to combine the wellbore preparation run with the actual whipstock run itself. So there's multiple different service companies have brought this technology to market. It's pretty much in field trials now, but it's saving the well prep run by sacrificially running mills and scrapers below the whipstock anchors, and that can save a trip, right? So in a high spread rate environment, that's significant. Okay, the systems, of course, are a higher cost because you're sacrificially running stuff in more equipment in the hole. But when your spread rate is in excess of a couple $100,000 US a day, that is a pretty big payoff from a reward standpoint. So I got a couple case histories. I pulled this one from Malaysia. So in this particular case, it's a sidetracking a depleted well. Couple things about this particular, what makes this somewhat unique that kind of highlights where we're at from a technology standpoint. Not necessarily the casing size here. 9 5/8 is probably the second most exited casing worldwide, but there's a centralizer at the junction point. So prior to the past couple years, and it's still kind of a no-no, you always want to avoid centralizers if you can, but if you have to cut through them, the technology there is to do it and still maintain a pretty high success rate. In addition to this, they needed to get an extended rat hole because they did not want to rotate the drilling BHAs, any components, the stabilizers, or the underreamers across the junction itself. So they run in with a normal system, cut the window and rat hole in 2.5 hours. So that's significantly below the average that we mentioned a slide or two ago. That was 9 hours. So it's groundbreaking speed at which it's being done, but the junction still is in great condition. No issues passing future BHAs or the completion. So it kind of sets the gold standard to which can be done. Extended length rat hole, cutting through bowspring centralizers on the backside and doing it in a record-setting pace. This would be a multi-trip whipstock 5 years ago, and certainly 10 years ago. You may not even be able to get a usable window. So this is a good example, comes from Malaysia. Here's one more. And I pulled this one from the Gulf of Mexico, and I try to sneak this one into every single slide deck I do worldwide for obvious reasons. You probably will never see casing this thick, this small. So it's only ran by one super major on high pressure, high temperature, deep wells in the Gulf of Mexico. It's 12¼ inch OD, and it's an inch and an eighth thick, and it's high yield material. So up until 2018, this pipe was thought to be unexitable. Can't cut a window in it, okay? It's been done 4 times now. Obviously, you can see the depths. It's super deep water. 3 of those times in a single trip, 22-foot window, 5,000 pounds of swarf, 9 hours. So it absolutely meets the global average as far as milling time. This is super deep, so it took about 5 days, so a couple days longer because of the depth. But the reason I put this in here is not only to show you what can be done from the standpoint of a technically challenging install. This kind of takes the cake when you're talking about cutting windows through heavy wall pipe. There's probably not anything out there that I know of that's more difficult than this, but it changes the way the operator looks at well construction. So when you look at it, of course, no one in Thailand is going to be running 12¼ inch thick casing, but because this can be done, there's not too much anywhere globally that can't be done. Now, in this particular situation, it's also a contingency. Now, what does that mean? If you can't exit the pipe and you don't want to spend the time fishing, the alternative to doing a sidetrack in this size prior to 2018 would be to back up into the 14-inch casing, do a somewhat challenging exit there, re-drill the whole section, run more of this expensive pipe, and continue operations. Now, when you're in contingency mode, as we all know, things don't go accordingly to plan. But the best case scenario on these type of wells, if you have to back up into the 14-inch and do an exit, it's 2 days minimum before you're back drilling. Continuing well construction, getting back down to the landing point for the 12¼ inch casing. Okay, so 5 days versus 2 weeks in a perfect scenario at $1 million a day worth of spread, not including lost production. That's significant. It changes the ways the operators will spend CapEx on well design because the well construction process is de-risked. If you run into a problem in a casing size and you have the ability to exit it, and you can get back to drilling in on average 3.5 days, deep wells 5 days, that changes the risk profile of well construction. It's important. That moves us quite nicely into plan contingency. As I said, half the wells sidetracked globally are in contingency mode. Something's happened, drilling rigs on location, you're burning NPT at that point. So we looked at a really good case history of what can happen when you're in drilling mode in a technically challenging operation that saves you time, right? Back to drilling in 5 days. It's changed the way people will do well construction and when they'll actually sidetrack. Multi-string exits, expandables, super heavy wall applications, but it's also changed the way that technology gets used to drilled wells in certain scenarios too. So 2 examples I have up here from a technology standpoint are fishing limited technology. So when I got into the oil field, say 15 years ago, it was always a general rule of thumb that you don't run non-OD fishable tools in your wellbore. And the reason is simple. If you can't OD fish it and you're limited to just ID fishing, you're always one fishing run away from being done fishing. Now, from a sidetrack perspective, if it's gonna take you 2 weeks to get a usable window, maybe that's not ideal. If you can't fish it or you're done fishing and now you're gambling on getting a sidetrack, that's a problem. But because we're now to the point where 97% of the time you're back to drilling in 3.5 days, it's changed the risk profile of running this equipment if you end up in a contingency situation. So 2 of them that I have up here, high torque pipe, slim hole application, and running rotary steerables. People choose to use this newer technology because you can get higher ROPs and longer lateral lengths to production and accessing more production. If you end up in a fishing situation with this type of technology, it's not the end of the world nowadays because you can sidetrack and be back to drilling in 3.5 days, assuming that you didn't leave a source in the hole or you have insurance obligations, right? So just another concept of the way that using newer technology has been de-risked because you can go around it much quicker. So when you speak to general fishing versus sidetracking, every operator on planet Earth uses some variation of the same equation that looks at what you left in the hole, what the risk or profile is of getting that out of the hole, how long it's going to take, and then offset what is the cost and time associated with doing the sidetrack. Okay, so we spoke to the statistics and the efficiency of sidetracking, but when you look at equipment costs, not new technology, but conventional equipment, the cost is down around a third in the past decade. But another factor is the amount of hole being drilled in every basin of the world has skyrocketed, right? So you can log on social media, say LinkedIn at any time, and probably within 5 posts, you're going to come across a drilling record in some basin. Thousands of foot drilled a day. That's much more than what it was last year or the year before or a decade ago. So if you can recapture lost hole quicker, that also changes the equation, right? The spread costs are ever increasing. It doesn't matter whether it's a land rig or a deep water platform or a drill ship. The costs from a service standpoint of the rig being on location goes up every single year. And that changes also the metrics as far as do I fish or do I sidetrack, right? All these different factors, including the efficiency of where we're at with sidetracking, has revolutionized the industry on how long people will fish. Now, this is a fact, and it's a for sure thing. When I started in the field, a lot of the guys that run Whipstocks did fishing operations, and it would be very common for them to be out on rigs fishing for a month, 2 months, 6 months on end. Highest paid people in the industry, all of them had 2 Porsches and 3 Harleys in the garage. That's not the case anymore. Operators do not spend near amount of the time fishing as what they used to, because you can sidetrack much quicker, much more efficient, right? A lot of operators out there, in most scenarios, not all of them, if there's not a situation where you feel comfortable that you're going to get the fish out of the hole within a week, you'll sidetrack. Make one attempt. If you get a good attachment to the fish, you'll jar for 12 or 24 hours, and if it doesn't work, you're coming out and picking up sidetrack equipment, because you know that 97% of the time you'll be back to drilling in 3.5 days. Now, no matter where I go across the world, I've been to 30 countries now giving this presentation, and usually someone after the presentation will come up and they'll say, yeah, this is 100% true. It doesn't matter where you go, but I'll speak to one example because it was probably the highest impact that I had. I was in Nigeria, and a drilling manager for a super major come up and said, man, 5 years ago we spent, I think he said 40 or 60 days trying to fish a completion packer out of a well. That doesn't happen anymore. He said, we already got sidetrack equipment shipping to the rig the minute we pick up a fishing BHA. By the time it gets there, we're coming out of the hole and going around it. This is true. This is not just a thought. This is reality. So here's one that comes from the Philippines, semi-submersible bypass. So they don't want to spend the time doing fishing operations. It's a shallow exit, right? Tide changes are a concern from a fishing standpoint. 9 5/8 casing again, so not a very technically challenging job. Shallow, less than 2,500 meters. They decide to go in and cut an 8.5 window and rat hole in a single trip with a hydraulic system, meaning they don't have a false bottom in the wellbore, and they did it in 21 hours. So there's a lot of installs that take less than the 3.5 days. It's all depth based, of course. So if the shallower you get, the quicker you can get it done. This fishing operation absolutely would have taken multiple days, even if they were successful. So doing this operation and getting sidetracked in less than a day, it avoids the cost of additional NPT of continued fishing operations. Well, construction continued as planned, right? This is just one example. As I currently stand up here and give this lecture, there's well more than a dozen of these type of scenarios going on worldwide where people are sidetracking in contingency mode. They do not want to spend the time fishing. They'll be back to drilling in just a couple days. Multilaterals and reentries. So we're shifting gears here, and the whole focus of this type of topic is going to be targeting reserves and reduce the cost per foot to do it. Okay, so the definition of a multilateral well is up there. It's very simple. Anytime you have a well with more than one lateral, it's a multilateral well. Okay. We touched on this a little bit when at the front end when we talked about drilling new wells relative to sidetracking wells. And anytime you have the opportunity to do a multilateral or re-enter an existing well that has integrity, you save well construction costs down to kickoff point, which in some cases is very, very significant, right? In addition to that, you reduce your surface footprint, all the infrastructure in place. You don't have to abandon another well, and it's a green concept. Utilizing existing mature field assets, when it saves trip count, reduces your carbon footprint, and it reduces time to get to production. So it does start checking ESG boxes when you go down the road of reentry or multilateral. So a lot of operators, of course, look at this concept of doing reentries or multilaterals, and some of them throw a little bit of money on the front end of a project to make the well geometry a little bit different and de-risk future reentry application. Not super expensive to do. Other operators are on the other end of the spectrum where they actually buy up slots or acreage with the intent to do full-scale multilaterals as the wave of the future, maximizing target reserves off of one well. So when you look at it generally, this isn't every basin, this probably isn't Thailand, but from a general perspective, when you look at oil and gas wells, globally, about half the cost and time to get down to kickoff point, so where you would actually cut the window, is spent on well construction. So if you're going to go drill a well, say somewhere on land, and it's going to cost you $10 million to do it, about half of that spend, $5 million will be down to kickoff point. So that's a significant savings, right? The shallower the kickoff point, the less this statistic comes into play, but it's certainly applicable to think about. There's always different options, right? Now, there's also the concept of, well, before I hit that, from a geothermal standpoint, it's actually significantly more, 70 or 80% in my estimation, because the top hole construction costs are more because of the larger casing sizes to handle the steam, and the completions costs are very much less so than in oil and gas, right? Stranded reserves, because we have lots of new technology out there, we can access production cheaper than what we could last year or 5 years ago or 10 years ago. So when operators go and they drill wells, they target the reserves that they can get most economical at the time they're drilling the well, right? So there's plenty of wells that have been drilled out there a decade ago, 2 decades ago, 3 decades ago, where reserves are behind pipe. They're uphole. They're behind casing, but they didn't target those reserves because they weren't economical at the time the well was drilled. But nowadays, because of the technology we have, you can go get those reserves on the cheap. Now, this was a huge concept during COVID, right? A lot of people couldn't get their hands on resources to drill new wells, and if you could, it was super expensive. So we saw the number of reentries skyrocket, because you can get on with a workover rig on land operations, re-enter some old 7-inch or 9 5/8 casing, target behind pipe reserves, get cheap production, cash flow, keep the lights on. This concept is still going on outside of COVID because a lot of operators realized how economical it was to get behind pipe reserves using the re-entry technique, right? Food for thought. So multilaterals, generally speaking, you see a bunch of examples of kind of stick diagrams of wells of what they multilaterals will look like. But one thing's for sure, there's only 2 ways to do multilateral wells, and that's to stack them vertically or lay them out horizontally. Now, when you talk about stacking them vertically, you either do it in the same zone and commingle, or you cross reserves, and you might have to deal with the pressure differentials across the different formations, right? Lots of different ways conceptually to do that type of well design. The upper left hand where you're crossing different pay zones, you might have to deal with different pressure gradients. More complex completions can be used to do a production from both zones using dual string tubing packers and things of that nature. You also have the option to go ahead and do well construction on one lateral first, produce it down, come back and do well construction on the second lateral, and eventually commingle. There's no necessarily right or wrong way to do it. It's just a little bit more challenging than if you have the ability to commingle from the start. So a lot of the zones out there where you have a formation that gives you integrity at the junction, meaning you don't necessarily have to run casing across the window. So the formation itself will support the junction. In those type of thick zones, that is a 100% candidate to do multilateral wells. And so one that comes to mind that I speak to all over planet Earth is coal bed methane. Formation's competent. You can do level 2 junctions, meaning you don't have to run liners back up into the main bore casing. And every single time you have a thick coal bed methane seam, and it doesn't necessarily need to be coal, it can be other formations that are similar as far as junction integrity, you can cut as many laterals in that you can fit. And there's currently wells that use this concept that are being drilled worldwide where they're accessing 60, 70,000 foot of reservoir exposure off of one well. That's groundbreaking. The amount of production that they get from a cost standpoint is incredible, okay? So that's vertical wells. Obviously, you're limited on how many laterals you can do based off the junction you put in there. But when you talk about horizontal type wells, like the lower right-hand picture that I have here, this type of design is referred to as kind of a gull wing or a fishbone design. And that's obviously commingled type production because it's coming from all the same pay zone. Now, when you look at this particular type of well design, the only thing you're limited on doing this is the actual slot or acreage that you own from a surface footprint standpoint. You can't go and drill into someone else's field, but as long as you have the acreage or the slot, you can target that with as many laterals that you can put in there that make sense from a production standpoint, right? Now, in these type of designs, they're usually quad laterals where you case off the main bore, and then you'll have 3 casing exits heading back up towards the curve and drilling laterals horizontally in the same formation across that actual main bore section. Now, when you look at this type of design, they do it in multiple countries around the world, but the most common place that they utilize this type of horizontal multilateral design is the Middle East. And they do it in scale and they've perfected it. So the statistics are a little bit skewed versus the 50% that we talked about of well construction costs and time to get down to kickoff point. There's a study out there that took a look at a vast majority of these volume level 2 quadrilateral designs, and it's almost a 1-per-1 lateral production gain as a new drill horizontal. But the cost is staggeringly low. So they get 393% production off a quadrilateral relative to a new drill single lateral, but the cost to do it is only 30% more. So when you're talking about these type of horizontal multilateral designs where you can use a level 2 junction, meaning that you don't have to run casing back up into the main bore, you can save a lot more money than the 50% that we statistically spoke about 2 slides ago. So here's one from Thailand. This is not one of those simplistic level 2 designs that I just referenced from a horizontal standpoint, but this is a really good story because it's utilizing existing assets, extending the well life, but gaining production off of a mature field asset. So in this particular case, they got 9 5/8 casing and they want to go ahead and run 7-inch. So they have to have isolation in this particular scenario, that there's still production coming down from the main bore that they want to keep, but they want to access some more production and not have to use a new platform to do it. So in this particular case, these are shallow exits done at a little bit higher inclination. But in this particular case, they cut the window like you normally would, single trip. You run conventional liner equipment, 7-inch, hang it off back up in the main bore. So it's at that point when you run it, it's not actually a junction because everything is behind pipe, it's behind cement, it's standalone wellbore. Any type of completion you want to do is only limited based off of the standard liner hanger pressure rating. So at that point, you start your new production after you TD that whole section. And the moment you want to go ahead and access the lower production, you simply run in with perf guns on coil or wireline and perf into the actual hollow whipstock to regain production from below. So at that point, it becomes a level 4 junction, right? So no pressure integrity issues up until the point you perf, which is when you want to perf. Now you got production from below, production from the new lateral, utilization of existing platforms, an incredibly low risk, low trip count solution. Certainly a concept that can be used on existing assets if you have integrity. Well depth is not critical. In this case, Gulf of Thailand, shallow, but it can be deeper. The deeper it is, the more well construction cost and time you save. All right, final topic, open hole sidetracking. So we're shifting gears. We're now outside of the casing, but the concept itself stays the same. You're running in the type of system that's made for open hole, but the process that we talked about at the beginning of the deck is somewhat the same. The deployment method may change, but I need to be clear about a couple things when we talk about open hole sidetracks. In this particular concept, we're not necessarily referencing horizontal sidetracks. And the reason why is the standard industry practice is to low side your motors when you're in high inclination. You don't even need to come out of the hole, right? So we're not referencing those type of scenarios. We're talking about the open hole sidetracks that happen back up into the curve or in the vertical section, where the other option is to pump cement. Now, we talked about that concept of cement plug during section milling operations, right? Pump your plug, wait for it to set up, hopefully it gets set up, and then you go time drill off. If it's unsuccessful, you rinse and repeat the process, right? So there's no kind of statistics that point to say doing open hole sidetracking from a cement plug standpoint is better at this depth or deeper. And the reason why is because as you get deeper, you typically fight harder compressive strength formations, which makes it difficult to get off plugs in some cases. In the softer formations, you're usually in a larger hole size, which can be problematic to get cement plugs to set up depending on what type of drilling fluid you're using. So there's not really an answer to say at this depth and this formation, the statistics get better, right? It's kind of wide open. But the one thing you do have to keep in mind is that the risk profile of using sidetracks in open hole is not the same as casing exits. They're not as reliable because you have to fight the open hole environment. Hole washout, general hole conditions. If the hole's not good, don't run an open hole whip. You only got one option, and that's cement, okay? Now, that's also important to consider where you're at relative to the casing shoe when you start talking about sidetracking. If you are reasonably close to the casing shoe, you always take the option to exit the casing because of the statistics we talked about, period. Okay? The best case scenario, if you get all the boxes checked as far as open hole environment, is 9 out of 10 installs will go well. The one that doesn't go well is usually not recoverable. So it's not like a casing exit where you just go and make another run, life goes on. It's usually not usable, okay? It doesn't mean that open hole sidetracking with Whipstocks is bad. It's just the statistics are not as good as casing exits, okay? So open hole options, obviously plenty of different types of anchors. You can run them hydraulically, you can run them mechanically. The main difference between open hole whipstocks and cased hole whipstocks are kind of two main points. One is a lot of the systems out there that you run in open hole, you have the ability to cement through. Whether it's for regulatory purposes or just an operator desire to pump cement for isolation, you have that ability in an open hole. You do not have it in casing. There's not a system out there that you can pump through a casing exit system. Now, because of that, a lot of the systems in open hole, you can run on running tool rather than cutting structure. Now, it increases the trip count to get sidetracked, but running on cutting structure running on running tool relative to cutting structure also buys you flexibility from a hole condition standpoint. If your hole's not in perfect shape and you run running tool, the OD of your BHA drops, allowing you to get through for some hole sections that may not be as great, right? If you're running on mills, you're full gauge. Hole's got to be in really good shape, right? So the ability to run on running tool, the ability to pump cement are two of the main differences. But one of the benefits to open hole whipstocks, of course, relative to cement plugs, is the well possession time it gets to get sidetracked. And I've got the statistic on the next slide. But the other benefit that you get is a fixed known depth and direction for kickoff. It's a mechanical system, right? It's giving you a point at kickoff point oriented in a direction and depth. When you use cement plugs to kick off, you may get off high, you may get off low, you may not get off at all, and the direction at which you go is simply controlled by how well the directional driller can hold tool face while trying to get kicked off. So when you look at a lot of the statistics out there, there's plenty of papers. This is one of them. I've wrote a bunch. Other people have wrote a lot more than me. But when you add up all the papers and articles out there, the conclusion is always the same. When you're talking about conventional open hole whipstock equipment, when you look at large scale operations where there was cement plug sidetracks done versus open hole whipstocks, when the application fits, meaning you have the option to do either, on average you save 2.5 days. Now that takes into account the failures and the successes on both sides. So the plug that you got kicked off of in 24 hours, the plug that took you 5 attempts to get kicked off, the whipstock that worked, the ones that didn't, all that boiled down, the outcome, the conclusion to every single one of these papers is about 2.5 days saved, right? Now you have to keep in mind that when you have an application where you start with 2 options, meaning your hull conditions are good, you're not super washed out, and generally you feel confident that you can get the systems to depth, that doesn't mean that you're going to have that same 2 options a couple days later or a week later. So if you go down the road of, I've got both options, but I'm going to try a plug first, and if that doesn't work, I'm going to fall back on open hole whipstock, that could be flawed thinking depending on the formation you're in. The longer you leave the open hole exposed, the worse the conditions get. So there's lots of formations where you have the ability to do both. You try a plug, doesn't work. 3 or 4 days later, the conditions have changed. You're never going to be able to get open hole whipstock to depth. So then you're stuck doing open hole sidetrack off plugs. If that doesn't work, eventually you lose the whole section. Now you're back up into the casing, which is ideal from a casing exit standpoint. But if that's a significant amount of footage, that's a bad day for the operator. So the new technology that's coming to the market for open hole systems is no different necessarily than casing exit equipment, trying to maximize or reduce the well possession time, the trip count. So we talked about the cement type of installations. The vast majority of them conventionally were run on running tool. The concept now is combining cutting structure with still maintaining the ability to cement. So it saves a trip in open hole when you have to do a cement job, either for regulatory purposes or the operator just wants to isolate. So in those type of scenarios, you get on depth, you do your cement job, set the system hydraulically, pull off the milling BHA and go ahead and cut the window. The alternative with the conventional systems would be, historically, you would pull the running tool out of the hole and then go back in with a dedicated drilling trip. So it reduces trip count, shoves that 2.5 days up to 3 days or 3.5. Last case history comes from China. Now, this is the exact opposite of what I told you at the beginning of this section we would talk about, but it's unique, so I threw it in here. It is a lateral sidetrack. 5 7/8 open hole. In this particular case, they have offset data to show that kicking off of plugs is not very reliable. 12-day average to do it. In this particular case, it also checks the box of contingency option because they're sidetracking around a stuck drilling BHA. So in this particular case, they did go out, they oriented the whipstock to the high side and did get kicked off in 4 days relative to the 12-day average that they'd seen before. So in this particular basin for this operator, it was a step change relative to kind of what plan A was. The difference is they're not low side sidetracking with the whipstock. They've got to go high side. So if you have the ability to do that in a lateral, a whipstock does become an option. You're likely running this on running tool and not cutting structure because you have to get through the curve. Running full gauge stuff on a whipstock through the curve in open hole is going to be difficult. So in this particular case, it de-risks the well construction process for offset wells for this operator in the same field. Primary plan change to open hole whipstock relative to cement plug, high side lateral exits. That was a lot to take in, but a couple of bullet points to wrap it up. Whipstocks are a reliable option. The risk profiles have changed. The efficiency at which they are getting sidetracks done in very technically challenging scenarios has drastically increased. The well possession time has drastically decreased, and it's changed the way the industry looks at sidetracking in all sorts of scenarios, right? So because these operations have changed and they're way more efficient, it's changed not only the way operators look at well construction, but also the technology in which they'll use to do it. So we gave a perfect example of the non-fishing friendly BHAs. People run those all the time now to get the higher ROPs, longer lateral lengths, knowing that if they end up in a situation where they get stuck or something happens, they can get back to drilling rather quickly, relatively speaking, to where we were 5 years, 10 years, 20 years ago, right? We had a high-level look at reentries or multilaterals. The whole concept is reducing cost per foot of reservoir exposure, putting more production, getting more lateral exposure off of one wellbore, or reentering existing assets that have integrity to gain production. Saving the cost and time of well construction down to kickoff point, and then just what we talked about, open hole whipstocks, maybe a reliable, economical operation when compared to cement plugs, but only if the hole conditions are applicable. Relatively gauge hole, good hole, generally good hole conditions, but also keep in mind if you're close to the casing shoe, reasonably close, you should always take that option because of bullet point 1. Casing exits are way more reliable. So plenty of questions out there. I'll start taking them.
Test.
Man, it was that good, huh?
If no, maybe I can ask first. Now I'm apart from Chevron. It's a very good, interesting, and I would like to ask: is that possible to do the sidetrack for the second time, just in the worst case that we sidetrack for the first time and the well path still bad, and then with this technology, can we do another time?
You mean multiple windows?
Yeah.
Oh, yeah.
Okay.
Yeah, as long as they fit inside the zone where you can do a sidetrack, yes, of course. Unfortunately, there's been wells where people have had to sidetrack lots of times and didn't intend to, but yeah, you can keep running them up hole as much as you want.
Okay.
Yeah.
Thank you.
So I'm just a crane guy, so this is going to be very simple.
It's okay.
But one of the biggest, I would say, barriers that they run into in Thailand here is well bays. And the platforms are usually limited to the number of well bays. So if you looked at it from that aspect, is reducing even platform design and overall CapEx by using your technology.
Yeah, no, you're spot on. So it's not just, say, Gulf of Thailand, but there's other places around where you know, it's more difficult and time consuming and costly and risk to get to do like a new platform or bring a drill ship over, right? And so I mentioned shallower wells, obviously from a kickoff point perspective, start to skew the cost and time saved of actual well construction, right? But there's plenty of wells that are re-entered that are less than 1,000 feet, right? Or 300 or 400 meters. And the reason why they do it isn't necessarily because the well construction cost and time is super significant, right? It's much less than the 50% average, but it's done because of the concept, like you say, in certain areas where you want to utilize existing platform. Now that becomes very important in offshore application. When you're talking on land application, it's usually driven by regulatory getting the permits. But no matter how you boil it down, it's applicable. Not in every basin and every single well. I'm not saying that. I'm just saying there's to spur thought process on if you have something that's usable, if there's no integrity, it's like you don't do it, right? But if you have integrity and it can save you, it can add value somewhere, then you can go drop a casing exit into it. So it's perfect in the Gulf of Thailand. The reason you just brought up is very applicable, right? I don't know that example that I put up there that was a shallower exit done in the Gulf of Thailand. They did 4 of them, right? The multilats. From a cost of well well construction time and money perspective, it's probably much less than the 50% than the global average.
And on the back end of that question would be, how important is the integrity of the existing wellbore?
Well, it's important as long as you're sidetracking above any problems. So what you run into if you don't have integrity above the sidetrack point, I suppose if you're going to run casing across it, you can remediate that. But in a lot of scenarios, if the pipe's that bad, you aren't, especially if you're talking about certain unconventional assets, you're not going to do anything with it because it won't hold the pressure on the backside, right? Certainly something to consider. If it's too bad and you can't even get well construction done, the only option at that point would be to start running patches and stuff, and the operation, this cost will skyrocket. So it's avoidable. So not every well's, certainly not every well. There's probably more wells that are not candidates than are candidates, but it's, the thought needs to be there. If you have something that has integrity, you should at least take a look and say, hey, what can I use this? Access production, save money doing it? Yes or no? Great question.
Maybe any questions from the students? Right at the back of the corner.
Nope. We got one back there?
Yeah, we've got a bunch of students there.
Oh, okay. I'm sure they got plenty of questions. Don't be shy.
Yeah, I'm sure the question, will this be on the exam?
Yeah, yeah. Hopefully you took notes. There's one.
Here. Your neighbor, yeah. Student. Yeah. My name is Bolat from Chevron. Thank you for the presentation. You mentioned that Whipstocks and the Sidetracks, they help to discover stranded reserves, right?
Oh, yes.
And technologies developed not only in sidetracking or the drilling aspects, also everywhere, right? The same as geophysics, geology. And over time, the likelihood of discovering sidetrack reserves is less and less because earth scientists and the petrophysicists and the geophysicists, all the technology develop, right? So it becomes really, really important to get to the original target. So maybe it's a bit of sidetrack from the main topic of today's presentation, but what's the statistical percentage, maybe, if you're aware, after sidetrack getting back to the original target?
That's a good question. I hope it's high. So, yeah, I mean, it boils down to this. I don't know the statistics of the operator reaching the target simply because all that stuff takes place when we're not there. And we just don't have access to the data afterwards. The only thing I can say is that if everyone's, the portion from a sidetrack standpoint, from an industry perspective, the goal, of course, is to get the usable junction for it's opening the gateway, right? It's the wellhead, if you will, of the new target. There's so many other things that once you have the usable junction that fall into play on getting to the target, right? You have to be able to drill the well as designed. And of course, the target has to be a good target. So I can't answer like how often it is that people get to that target from a statistical standpoint, but I would say the amount of times we've been involved in operations where we sidetrack to hit not necessarily behind pipe reserves, but original target zones, say like on exploration wells, is pretty high. Not often do people deal with those type of wells and then get dry hole. Not to say it's unheard of, but it's pretty rare. I can't give you an exact statistical number, of course, but people do that all the time, especially in new plays, right? Chevron does it all over the world. Big time sidetrackers, especially in North America.
Thank you.
There's one. Oh, the gate's open now.
Oh, you just say hi. Okay.
No, he doesn't. He backed
Just saying
up.
hi.
He changed his mind.
Any questions from a student? Don't be shy. Okay, so no more questions. So thanks, Tom, for delivering your lecture. So let's give a round of applause to Tom.
Thank you, Mr. Tom. For the next step, I would like to ask Kun Ning to give the award to the speaker. Yeah. มีใครถ่ายรูปไหม Yeah.
Thank you. Thanks so much for having me. I'll be around for a little bit if there's any questions.
เป็นสไลด์หน่อยครับ Okay, before Lucky Door, we have some closing remark. For the next month, we will have a highlight meeting for this year, SPE Thailand season opening. This year is our honor to have Dr. Sean Guest, President and CEO from Velula Energy, to give the talk about the topic energy transition doom. No, but it's boom. So, for oil and gas industry, for this event, we also would like to give the floor to our future, the young professional, Kun Pornpan. She's a reservoir engineer from SLB. She's a winner of SPE Thailand Young Professional Presentation Contest last year. So this would be a great meeting and dinner, and please feel free to join us. Please stay tuned for our registration coming soon. For our neighbor SPWLA, they will have a topic of the how, why, and what of rotary wildlife calling by Kun Marvin from GoWell. You can register this event in the SPWLA link. And for the exhibition conference, there are SPE IADC Asia Pacific Dueling Technology Conference and Exhibition, or APDT, which is hosted by PTTEP in August 2024 next year. That already called for the abstract submission, and please invite your colleague to submit. Also, check out the SPE Asia Pacific website for the upcoming event. And there are many ways to get in touch with us, SPE Thailand section on the SPE Thailand website. Follow and like us on Facebook at Society of Petroleum Engineer Thailand section or at SPE Thailand. On the LinkedIn and join SPE Thailand section group, we also have a Line official account where you can follow our upcoming event, register, and even apply for the membership for SPE. You can scan any QR code in the screen, so it should direct to the link. So, and last but not least is the lucky draw. So may I invite Mr. Tom Emelander to draw the lucky draw for our audience today. Yep, we will have 2 lucky draw.
2 of them? 2. First one. Oh my God. Everyone's going to hate me for this.
The first one is from Weatherford, Benjamin. I'm not sure that's the name. Benjamin.
No, not Weatherford there.
Okay. And the second one is Jose Company. I'm not sure how to spell. Jose. Okay. Mr. Tom, can you give the award to the lucky person?
Get one that match.
There you go. I don't know.
Oh, you got a mom.
Oh, Weatherford Red, right?
First time for Jose, right?
And also we want to promote the scholarship of this year. So for the student, in our student chapter, we have the scholarship as shown in the screen for Chulalongkorn, Suranari, Chiang Mai, and Prince of Songkla University. And it's required that you need to be the SPE membership for the student. And the upcoming event for young professional, we will have a presentation contest this year. And the date will be in November. But abstract submission deadline will be 30th of September in the next month. So we will have if you feel to finish your glass here in the room, and if you still want a couple of more drinks, we have arranged special SPE Thailand drink at the bar on the ground floor in the lobby level. So tell them that you come from SPE meeting and the secret password is SPE. So they will give you 2 drinks for the price of 1. So finally, this company are the sponsor who support us, our Thailand monthly technical meeting for this season. For any of you who may just tune to this meeting, if you would like to see your company name in here, please reach out to us. We appreciate your support and of course, our society needs you. Thank you for today. Thank you for your time.